Students, now we are in the topic of circles, which is a lengthy topic. In previous class, we discussed exercise 1D, Roman number 1, 2 sums we have completed. Now let us going to discuss about exercise 1D, Roman number 3 sums. I put a schedule in previous class also, 1, 2, 3, 5, fourth one you do. First question, find the coordinates of points of intersection of tangents. Find the coordinates of points of intersection of tangents. Find the coordinates. Coordinates of points of intersection of tangents. Find the coordinates of points of intersection of tangents. At points where x plus 4y minus 14 equal to 0. Where x plus 4y minus 14 equal to 0 meets the circle x square plus y square minus 2x plus 3y minus 2x plus 3y minus 5 equal to 0. Here the question he given in indirect model. We should calculate the locus of points of intersection of tangent drawn at extremity set chord. Wherever the line drawn, where the line he given as x plus y minus 14 equal to 0. So indirectly he is asking that find the pole of the line with respect to circle. Directly he did not give, we should try to understand the concept. So you should calculate only pole. Given circle, you write. Given circle S is equal to x square plus y square minus 2x plus 3y minus 5 equal to 0. According to 2g concept here, 2g equal to minus 2, g is equal to minus 1, minus g is equal to 1, 2f equal to 3, f equal to 3 by 2, minus f is equal to minus 3 by 2. Again r square we need. R square value g square plus f square minus c. So this is 1 plus 9 by 4 plus 5. 5 1 6, 6 4 the 24, 24 plus 9, 33 by 4. Now given line formula x plus 4y minus 14 equal to 0. The line here L is equal to 1, M is equal to 4, N is equal to minus 14. Write the formula pole. Pole is equal to minus G plus LR square by LG plus MF minus N, comma minus F plus MR square by LG plus MF minus N. Using the formula, substitute the values and get the pole. Pole P is equal to the value minus G is 1 plus LR square, L means 1 into R square means 33 by 4 whole by LG. L means here 1 into G, G value minus 1 plus M is 4 into F value 3 by 2 minus M is here plus 14 comma minus F Here minus f is minus 3 by 2. Minus 3 by 2 plus mr square. M is 4. R square means here 33 by 4 whole by L into G. This one you can write 1 into minus 1 like this. Plus M is 4. 4 into 33 by 4. Sorry, 4 into F value here 3 by 2. F value 3 by 2. 4 into 3 by 2 plus 14, that is n value. That is equal to, here we can write 1 plus 33 by 4 whole by, take an LCM here, this is 14 minus 1, 13, 13 2s are 26, 26 plus 12. 14 minus 1, 13, 13 2s are 26, 26 plus 12, 26 plus 12 whole by 2 comma, here minus 3 by 2 comma, minus 3 by 2, don't cut this one, 4 into 33 by 4, leave like this, 4 into 33 by 4 by the same method, 14 minus 1, 13, 13 to the 26, 26 plus 12, 26 plus 12 by 2. So you can write here as 1 plus 33 by 4 into 2 by 38. 2 by 38 comma, here minus 3 by 2 plus 4 into 33 by 4 into 2 by 38. Here now 4 get cancelled, 2 becomes, will be getting cancelled as 19 times. Here this 2 get cancelled. 1 plus 33 by 76, comma, here take an LCM 19 and 2 LCM is 38. So here you can write 19 into 3 minus 57 plus this is 33. You can write as 76 plus 33, 6 to 3, 9, 7 to 3, 10. So 109 by 76, comma, this is minus 57 plus 33 becomes minus 24 by 38 or minus 12 by 19. 4 got cancelled, this is 2 times, this is 2, okay, 2 by 19, correct, 19 to the LCM minus 57 plus here 2 into 3, students, here 66 you should write, 2 into 33. So it is 66 minus 57. 66 minus 57 becomes 9, 9 by 38. This is the pole. So in indirect way he asked it to us. Let us discuss about second question of Roman number 3. This is most IMP concept, IMP 4 marks from an IIT, and this is IMP JEE question also. Same question we may face in level 1 classwork, level 2 classwork also. Roman number 3 second question. If polar of points of circle, if polar of points of circle, if polar of points of circle x square plus y square, polar of points on the circle, not of, polar of points on the circle, polar of points on the circle. Polar of points on the circle x square plus y square is equal to a square. Polar of points on the circle x square plus y square equal to a square with respect to circle with respect to the circle x square plus y square is equal to b square, touches the circle, touches with respect to the circle x square plus y square equal to c square, touches the circle x square plus y square is equal to c square. Then prove that A, B, C are in geometrical progression. Then prove that A comma B comma C are in geometrical progression, GP. A, B, C are in GP. A, B, C are in geometrical progression. This is IMP 4 marks or IPE and objective. MSET comma mains. I mean, this concept is most important. Here you observe the circles x square plus y square equal to a square, x square plus y square equal to b square, and x square plus y square equal to c square. Three circles are having same center, different radii. So wherever the three circles having same center, different radii, we can say that the circles are concentric. Given circles, I am writing. Given circles, you can write as x square plus y square is equal to a square. This is the first circle. And x square plus y square is equal to b square. This is second circle. And x square plus y square is equal to c square. This is third circle. Let the names of 1, 2, 3. Try to understand the question, what you should do, what he given. If polars of points on the circle, so the polars on the circle means the point on the circle. This polars of not this circle. Whenever he given with respect to, there only you should try to understand that you should calculate the equation of polar. Yesterday also I said that whenever with respect to he given, then only you should calculate the equation of polar. So here you should calculate polar. Polar of this circle. Whenever with respect to he given, there you should calculate polar. So polar of second circle. To get the polar of second circle, a point we used to take from outside or inside or anything in the plane of circle, the point should lie on this circle. So the point lie on this circle. So point x1 comma y1 lie on 1. From the point, if we have taken a secant, the points of intersection of tangents drawn at extremities of chord is polar. So polar of second circle. Now read it once again. With respect to the circle, touches the third circle. So polar of second circle, where the points lie on the first circle, touches the third circle. Then you should prove that ABC are in GP. Let us draw the diagram. Then you can understand. Put here, this is the first circle, this is second circle, and this is third circle. From here, we should take px1 comma y1 point. Whenever the px1 comma y1 point is outside of the point of x square plus y square is equal to b square. So from point to get the polar, from any point, external or internal, anything in the plane of circle, we should draw a secant. That secant should intersect the circle in two distinct points. So draw like this, in two distinct points. Put the name here, this is A and this is B. Take the extremities of chord. This is a tangent and this A and this B. Draw the tangents at extremities of chord. The points of intersection of tangents drawn at extremities of chord is called as polar. So this is polar of 2. Of course, the polar became tangent to 3 here. Tangent of 3. That's all. So polar of the second circle became tangent of third circle, where the point, to get the polar equation, where the point is, there the point should lie on the equation of first circle. Now, by condition I am writing now. By condition. By condition we have Px1 comma y1, Px1 comma y1 lie on 1. Whenever the Px1 comma y1 lie on 1, then substitute the value instead of x1 and instead of y1. So you write x1 square plus y1 square minus a square equal to 0. Let it be fourth equation. This will be useful. Now you write equation of polar. Equation of polar with respect to second circle is the formula S1 equal to 0. The formula S1 equal to 0 is notation xx1 plus yy1 minus b square equal to 0. Try to understand, this became a line. That line is tangent to third circle. Whenever a circle is tangent to, whenever a line is tangent to a circle, then you should calculate that r is equal to d. This is r, this is d. The center here 0, 0 and radius is c. Here radius of third circle is c. Since you write since I am writing directly, since this is a tangent, means this polar, since this is a tangent to 3, so tangent to third circle, whenever this is tangent to 3, use r is equal to d. Using r is equal to d, right? So what is r? Radius of circle. And what is d? Perpendicular distance from center to the line. That implies here c is equal to perpendicular distance from 0, 0 to this line. You can write modulus of minus b square by root of x1 square plus y1 square. That implies c is equal to, here you write b square by, what is the value of root of x1 square plus y1 square is equal to a square. So root a square you write, if you are having any doubt from 4 you put there. That implies now you can say CA is equal to b square. Therefore whenever b square is equal to AC, therefore a comma b comma c are in GP, that is geometric progression. In sometimes in objective he may use this is b square, this is a square, this is c square. So whatever the values are there, same concept you can use and change the values. In sometimes he given, let prove that BC are geometric progression, CAB are geometric progression, C square is equal to AB, C is equal to root AB, like that plenty of times he changed the concept and given the concept is same and changed the letters. CAB are in GP, otherwise C is equal to root AB, otherwise ABC are in GP, like that he given the question. But concept is same, don't forget, I think this is in CUQ, this is a level 1, this is a level 2. Objective, for objective this is most IMP question. Let us discuss about second question, first question completed, second question completed. Now let us discuss about third question, Roman number 3, third question. Tangents are drawn to the circle. Okay. Area of triangle followed by chord of contact. Using the formula of area of triangle, theorem I said. According to the theorem, we can discuss now. Roman number 3, third question. Tangents are drawn. Tangents are drawn to the circle. Tangents are drawn to the circle x square plus y square equal to 16 from the point P he given as, from the point P 3, 5, find the area of triangle. Find the area of triangle. Find the area of triangle formed by these tangents and chord of contact. These tangents and chord of contact. These tangents and chord of contact of P. I said the example and we proved the theorem as area of triangle formed by two tangents drawn from an external point where the chord of contact, I mean joining the points of contacts of both circles is chord of contact. Here P we put the name and here A and here B. We proved that S11 power 3 by 2 into R by S11 plus R square. Depends upon that one you should calculate this area. Area of triangle directly you write PAB. That means area of triangle formed by tangents with the chord of contact. Area of triangle PAB formula S11 power 3 by 2 into R by S11 plus R square. S11 plus R square. We proved in example. Now what is S11? What is the point? He given 3, 5, substitute in the given circle, and what is R means R square is equal to 16 and R becomes 4. Use the formula. Now S11 I am writing. S11 means here you can write as 9 plus 16, 9 plus 25 minus 16. 9 plus 25 minus 16. Substitute the value. 9 plus 65 minus 9 plus 25 minus 16. 35 minus 16 becomes 18. Enough. That implies area we can calculate. What is the S11 here? 18. So 18 power 3 by 2. 18 power 3 by 2 can be calculated as 18 root 18. Into what is the R here? 4. What is S11 now? S11 means simply whatever the value we got here 18 plus R square means 16. Now you can write here 18 root 18. 18 root 18 into 4 by this is 34. 2 table will be dividing in 9 times and 17 times. 9 4s are 36. 36 into this you can write as 3 root 2. So 36 into 3 108. You write as 108 root 2 by 17 square units. This is also is there in objective. Some sums which are not important I am discussing with you means it is important for objective. For objective only I want to tell the sums. Whatever the based concepts. What is based concept means depends upon the area of triangle like this. So based concept means basic concepts here. So depends upon basic concept I am going to discuss with you for only objective, not for IIT. This sum maybe is there in objective level 1. Now this is 5th question. Directly I am writing here students, CUQ is there in objective, conceptual questions, 19th question is there. It is useful for mains. So CUQ 19 I am writing directly the question which you are going to face in objective. CUQ 19 I will not say hereafter. This is the question whatever I want to discuss with you. CUQ 19th question for mains you write. This is for mains. Mains and here example Roman number 3 5th question. Roman number 3 5th question. Find the locus of foot of perpendicular drawn from origin. Find the locus of foot of perpendicular drawn from origin to any chord of circle. To to any chord of circle, S is equal to x square plus y square plus 2gx plus 2fy plus c is equal to 0, which subtend a right angle at origin. Which subtend a right angle at origin. This is the question. Same question is there in CUQ 19. Find the locus of foot of perpendicular from origin to the circle. This is general circle. A general circle, yes. S is a general circle. For the general circle, find the locus of foot of perpendicular. For the foot of perpendicular, you should draw. Locus of foot of perpendicular from origin. If you take here 0, 0, from there to you write here, this foot of perpendicular of origin to any chord, let us put here. This is a chord. Px1, y1. Px1, y1 is the foot of perpendicular of the chord from origin. Find the locus of foot of perpendicular from origin to any chord of circle which subtend a right angle at origin. So this chord is making, of course this is like this. This chord is making a right angle. That the meaning is the line joining the points of intersection joining to the origin. The line joining points of intersection of the lines joined to origin, we know very well that in exercise 1C concept, in exercise 4C concept in 1B textbook, that homogenization. So now you have two concepts. First one, you should calculate the equation of a chord. Put here, this is O, this is P, this is A, this is B. You should calculate equation of chord having this one Px1 y1 with slope, with ulta slope, that means with minus 1 by m slope of O by P. OP is equal to y1 by x1. Now slope of chord is minus x1 by y1. Using slope of chord minus x1 by y1, you should calculate the equation of chord, and whatever the chord you get later, you should homogenize this one because it is making an angle 90 degrees with the origin. Then points of line joining points of intersection to the origin is the process nothing but homogenization. After homogenization, you should calculate the coef of x square plus coef of y square equal to 0. Then you will be getting the answer. Sum is lengthy sum, but in CUQ is there, in mains also. In the AEEE days he asked the question. Of course, not only AEEE, not only mains, so many competitive exams is there. Competitive exams are there. For the competitive exams, you should know the theory and concept regarding this sum. Slope of OP, right? Slope of OP equal to y1 by x1. Slope of OP is equal to y1 by x1. Since chord perpendicular to OP, slope of chord is equal to minus x1 by y1. Now we can write equation of chord. Equation of chord formula: y minus y1 is equal to minus x1 by y1 into x minus x1. That implies, taking cross multiplication, we get y by 1 minus y1 square is equal to minus xx1 plus x1 square. That one you can write as xx1 plus y by 1 is equal to x1 square plus y1 square. That implies you can write this one as xx1 plus y by 1 by x1 square plus y1 square is equal to 1. Let it be first equation. Now, given circle can be written as x square plus y square plus 2 into gx plus fy into 1. I think you remember the concept which you used in first year. 2 into gx plus fy into 1 plus c into 1 square equal to 0. Let it be second equation. Now we can write homogenizing 1 into we get. Homogenizing 1 comma 2 we get. That implies substitute the value instead of 1 this one and instead of 1 square this one. Carefully we should do the calculation. Here you write x square plus y square plus 2 into gx plus fy into, instead of 1 you substitute the value xx1 plus yy1 by x1 square plus y1 square, put a bracket here, plus c into, for this one you write as xx1 plus y1 whole square. I am writing directly, whole by, for denominator also you should write as x1 square plus y1 square whole square, for total whole square is there, within the bracket you put in 0. Now take an LCM. What is the LCM? x1 square plus y1 square whole square is the LCM. x1 square plus y1 square whole square, x1 square plus y1 square whole square plus 2 into, already x1 square plus y1 square is there here. Then you can write here as 2 into gx plus fy into xx1 plus y1 into, this is x1 square plus y1 square, x1 square plus y1 square plus c into xx1 plus y1 whole square, xx1 plus y1 whole square equal to 0, the total value. Now we can expand, this is x1 square plus y1 square whole square into, students I did not write here, into x square plus y square. So we can adjust now. Here x square plus y square into x1 square plus y1 square whole square I am writing. This is x square plus y square into x1 square plus y1 square total whole square. So now we can multiply. If we can understand directly, we can write that since the angle is this is 90 degrees, angle AOP is equal to 90 degrees. Since I am writing here, since angle AOB is equal to 90 degrees, that implies coef of x square plus coef of y square. Coef of x square plus coef of y square equal to 0 for the circle. Here, how we get the coef of x square? Here, x square coef and y square coef is as it is, x1 square plus y1 square whole square you can write. No problem there. x1 square plus y1 square whole square. Next, for this one, here 2gx is there. Students, gx into x, gx square. The coef of x square becomes gx1 into x1 square plus y1 square, directly you can write. So in the similar way, y square coef fy into y1. So fy1 you can write. So directly you can write as 2 into gx1 plus fy1 into x1 square plus y1 square plus later. For this one, if we expand this one, it becomes x square x1 square plus y square y1 square plus 2x x1 y1. So x square coef y square coef only you take. So x square coef becomes x1 square plus y1 square. That's all. And y square coef I have written directly x square co f x1 square plus y square co f y1 square along with c is equal to 0. You can write. Now you can do one thing. For everything x1 square plus y1 square common is there. So you can write divide by x1 square plus y1 square both sides. That implies. Therefore locus, you write locus of px1 comma y1. Locus of px1 comma y1. x1 square plus y1 square plus again circle we got. 2 into x square may get. Just wait for a bit. The answer I know. 2 into x square plus y square plus 2gx plus 2fy. 2 into how will be getting x square plus y square. X square coef is there. Of course, coef of x square coef of y square separately we should write. Not to come. X square coef and y square coef. Now separately we should write. X square coef x square plus y1 square is there and y square coef is also there. So x is directly I am getting 2 into a. Because x square coef x1 square plus y1 square and y square coef x1 square plus y1 square. Coef of x square plus coef of y square. Directly we can write now. So that implies this becomes 2 into divided like this. So locus you can write 2 into x square plus y square plus 2gx plus 2fy. 2gx plus 2fy plus c equal to 0. 2 into x square plus y square plus 2gx plus 2fy plus c equal to 0. Because this is CUQ important, I know very well. 2 into x square plus y square plus 2 into 2gx plus 2fy plus c equal to 0. For object to CUQ 19 I said, there I will not be handling the question, try to understand, write the question. Whenever we are facing the objective question, same answer you write in that notes. Now, we have completed successfully exercise 1D. So, exercise 1E concept is there. Let us discuss about the common tangent and relative position of concepts. Relative position of two circles. In the circles chapter, 2 7 marks are there. 1 7 mark you will be getting from exercise 1A and another 7 mark you will be getting in exercise 1E. Whatever now I want to discuss with you the topic. That is the most IMP topic for IPG, MSET and objective also. In MSET one question you will get in MSET one question regarding this exercise 1E concept. So concept depends upon exercise 1E. The concept is common tangents. The topic circles only common tangents. Concept name is. If a line, put side heading. If a line is tangent to 2 or more circles, common tangents. If a line is tangent to, if a line is tangent to 2 or more circles, then the line is said to be common tangent of those circles. Common tangents of those circles. Points of contacts are formed depends upon the number of circles or position of circles. Points of contact. Points of contact forward depends upon the position of circles. Position oblique number. position or number of circles. Example, let us draw like this. Now what is happening? This is the common tangent. So this is 1 point of contact, 2 point of contact, 3 point of contact. Now draw like this. This is also common tangent. A tangent means the line which touches exactly the circle is called as tangent. This is 1 point of contact, this is P and this is Q. Now, position why you are saying, sir, these are external positions. Now, just simply touching. So, what is happening? Only 1 point of contact. Sir, 2 circles are there, 2 points of contact may be formed like that, you should not argue, because that is why I said position or number of circles. If the number of circles, 3 circles are there, 3 circles are, one is outside of the other respectively, then one tangent can be drawn. If a tangent can be drawn, maybe the points of contact here, one separate. Line is one and points of contact are different. But here the lines are touching each other externally. Then it becomes only one tangent, is called as common tangent. Now separate, we have drawn separate 2 tangents, separate 2 circles. Then only one tangent. If you draw one tangent, this is a point of contact and this is a point of contact. Now let us discuss another example. Now what happened? One circle lie inside the other and touches internally. This is called as touches internally. Now what happened? Now this is the tangent. Draw properly. This is the tangent. So what is happening? The line is touching the 2 circles externally. Then what happens? This is the P, x1, y1. Only 1 point of contact. So if a line tangent to 2 or more circles, then the line is said to be common tangent of these circles. I said means 2 or more circles. But point of contact of the tangent and circle depends upon the circles and number of positions and number of circles or position of circle. Now let us discuss about the relative position of circles. Relative position, which is most IMP concept. Relative positions. Put side heading relative position of circles. Relative position of circles. To get the relative position of circles, depends upon relative position of circles. Total 5 cases are there. Let us write case 1. Detail picture we need. Case 1. 2 circles lie outside of the other. 2 circles lie outside of the other. 2 circles lie outside of the other. Now let us draw the diagram. Here 2 circles lie outside of the other. Draw like this and draw like this. Here for 2 circles we have drawn 2 tangents for this and this. The 2 tangents intersected at a point at external of 2 circles. For the 2 circles again we can draw tangents in between like this. In between. Now what is going to happen in the theory I want to discuss with you. This is center C1 and this is center C2. 2 circles here. put here, draw, this is R1, the point of contact. Let these two tangents intersect at point P, put here T1 and put here T2. This is T3, this is T4. And this is T5 you can put here. This is T6. Of course you can mention with any letter. T means tangent, students. This is T7 and this is T8. Wherever the points of contact formed. Now what did you observe? Total two tangents outside. Entirely outside of two circles. Two tangents for up, down. So two tangents having two up and two down. To upside a point of contact here 1, 2, 3, 4, like this. Total 4 points of contacts forward for the two circles wherever the tangents are drawn externally. But in between the two circles, if we draw tangents, then in the similar way we can get here 1 point of contact up, down for two circles. So total 8 points of contact formed. Now what I said depends upon position of circle. Now we got 8 points of contacts. We have drawn 4 tangents. Now what is the reason here? What now I want to discuss with you. This is C1, T1, right? This is R1. This is also R1. This is R1. This is R1. Because from center to any point it is called as radius. In the similar way you can write this is R2, this is R2, this is R2, this is R2. Ready? Now join like this. Let the outside point intersected at point Q and inside point intersected at point P. We know that, students, angle in semicircle is 90 degrees. How the semicircle formed? If a diameter is there, I mean from center to any point of the circle is called as radius, and 2 radii is equal to diameter. The longest chord which is passing to the center point is called as diameter. C1, T5 is R1. So where the diameter extends, the radius extends, it becomes diameter. The diameter divide the circle into 2 equal parts. The parts are said to be semicircle. Angle in semicircle is 90 degrees. Here like that you put here also 90 degrees. Here also 90 degrees, here also 90 degrees. In the same way here, you can put. Using similar triangle concept I want to discuss with you. Now, in triangle, using similar triangles I want to discuss with you. Using similar triangles. Using similar triangles C1, T1, P and C2, this one, T4, P. Triangle C1, T1, P, comma, triangle C2, T4, P. Let us draw the diagram like this, like this. What is happening here? C1, this is C2, this is T4, this is T1. Now we know that this is right angle. So this is right angle. This is common side, this is P. Common side base, this is a base and this is base. So what is the base? Opposite of hypo. Opposite of right angle triangle is hypo, and this is also hypo, I mean hypotenuse. So by RHS theorem, RHS means right angle, hypotenuse side. By RHS theorem, the two triangles are congruent. Triangle C1, T1, P congruent to triangle C2, T4, P. Triangle C2, T4, P. So what is happening? Side by side is equal to side by side, like that you can put here. C1, T1 by C2, T4. C1, T1 by C2, T4 is equal to C1P by the ratio C1P by C2P. C1P by C2P. That implies C1, T1 by C2 T4. Of course T2 also you can write, no problem. Here you can put T2, here you can put T3, anything. There is no question of letters confused. C1 T2 T1 by C2 T4 is equal to C1P meaning, C1 T1 meaning R1 and C2 T4 meaning R2. So you write like this. Directly you can write R1 by R2 is equal to C1P by C2P. That implies I am writing as C1P by C2P. C1P by C2P is equal to R1 by R2. In the same model, we can use this large triangle using external tangents C1 T6 and C2 T8. In once again I am saying, in triangle C1 T6Q full, C1 T6Q comma C2 T8Q, C2 T8Q. Draw the rough diagram like this. Like this you can put. This is a C1. This is T6. So better to draw proper way. I am writing directly. Put like this. And put like this. This is a C1 students. This is C1 T6. This is C2. Upside if you are not able to visible. Here I am writing. This is a C1. This is a C2. This is a T6. This is a T8. So C1, this is large circle. Here also the concept T6, this is 90 and this is 90. So right, according to large and small concept, triangle C1 T6. In triangle, in C1 T6Q and C2 T8Q, congruent concept I am writing. Congruent concept. So these two triangles are concurrent. Triangle C1 T6Q is congruent to triangle C1 T6Q is congruent to C2 T8Q. Here this is Q. So you can say here as C1 T6 by C2 T8. C1 T6 by C2 T8 is equal to C1 Q by C1 Q by C2 Q concept. C1 Q by C2 Q. That implies you can say here this is R1 by R2. Now you can write as C1 Q by C2 Q is equal to R1 by R2. But why the theorem you are discussing now with us, you can get a doubt. I want to discuss with you the concept of common tangent if two circles lie one outside of the other. Now, what is C1P by C2P? Here P is the point of intersection of the tangents, two tangents between of circles, and here Q is the point of intersection of tangents outside of the circles. Then C1P and C2P, that means we want to discuss with you, P divides the two circles in the ratio R1 is to R2 internally, and Q divides the circle and Q divides the tangents in the circles. Here P divides the tangents in the ratio R1 is to R2, and Q divides the tangents in the ratio R1 is to R2 externally. If Q is external point, the ratio is external, and P is internal point, the ratio is internal. Now therefore I am writing P divides C1 C2 you can write. That meaning not tangents, C1 C2. So line joining centers. P divides C1 C2 in the ratio. P divides C1 C2 in the ratio R1 is to R2 internally. P divides C1 C2 in the ratio R1 is to R2 internally, and Q divides C1 C2 means here line joining C1 C2 in the ratio R1 is to R2 externally. Once again I will say the formula also. You should remember the, of course proof with no need to remember, but concept you should remember. P divides C1 C2 in the ratio R1 is to R2 internally, and because it is inside of the circle, Q is outside of the circle. Like that you remember. P divides the C1 C2. C1 C2 means line joining the center of two circles in the ratio R1 is to R2 internally, and Q divides the C1 C2 means line joining the centers in the ratio R1 is to R2 externally. The conditions I am writing now. In the similar way, if C1 C2, if the two circles lie outside, this is the theorem I said. Now I want to discuss with you some points which are most important for sums, objective, mains, and MSET and IP to discuss the concept. Now I am writing case 1. Case 1. If two circles lie outside of the other, if two circles lie outside of the other, that is the condition. C1, C2. Q, and this is P. Join like this. Now what is happening? This is R1, this is R2. Now you can try to understand that first point. In this case, first point, C1 C2 greater than R1 plus R2, because C1 C2 distance is totally greater than R1 plus R2. This is the main condition. Next one. 4 common tangents here. The concept is 4 common tangents. 4 common tangents can be drawn. 4 common tangents can be drawn to the two circles. 4 common tangents can be drawn to the two circles. They are, the name I am saying, they are two transverse common tangents. Transverse common tangents. Two transverse common tangents. And two direct common tangents. Two transverse common tangents and two direct common tangents. What is the transverse? What is the direct? Whatever the tangent is directly touching, not simple touching. This here the points is simple touching. This is directly touching. So this is direct. I am writing here. This is direct. Outside tangents is direct. Inverse tangents is transverse. Write like this. Transverse. Next, fourth point. The point of intersection of transverse common tangent. The point of intersection of transverse common tangents. The points of intersection of transverse common tangents is called as, remember the name, internal center of similitude. Internal center of similitude. Internal center of similitude. The point of intersection of transverse common tangent is called as internal center of similitude P. General notation ICS means internal center of similitude. Next step you write ICS divides line joining centers. Line joining centers you write as C1, C2 bar in the ratio R1 is to R2 internally. R1 is to R2 internally. Therefore, you write here P is equal to the internal ratio formula R1x2 plus R2x1 by R1 plus R2, write like this. The formula M1x2 plus M2x1 like that. Otherwise Mx2 plus Nx1 model. Next you write R1y2 plus R2y1. This is y2. R1y2 plus R2y1 by R1 plus R2. This is fifth point. Next sixth points. Regarding the theory, if you know theory, you can do sums. The point of intersection of direct common tangents. The point of intersection of direct common tangents is called as external center of similitude. Is called as external center of similitude. Because it is outside. External center of similitude. Q. Within brackets, its general notation is ECS. Next to the seventh point I am writing ECS divides the line joining centers. ECS divides the line joining centers. Line joining centers C1, C2, put a bar. In the ratio R1 is to R2 externally. In the ratio R1 is to R2 externally, that is equal to ECS formula you write like this. R1x2 minus R2x1, the external ratio formula R1x2 minus R2x1 by R1 minus R2 comma R1y2 minus R2y1 by R1 minus R2. This is the most IMP concept. How many points are there here? 7 points we got. First one, in this case, first this two circles lie outside of the other. Whenever two circles lie outside of the other, then the condition is C1, C2 greater than R1 plus R2 and 4 common tangents can be drawn. The P is called as in point of internal center of similitude and Q is called as external center of similitude. In the similar way, internal center of similitude we have calculated, external center of similitude we have calculated. Okay students, let us going to discuss next topic in next class. Don't forget, this is IMP topic.